Let's do these new problems for machine. Okay, so this is a landing gear, and I remember the first steps. I was to tell you to do that is to split in different elements with the pin connection. So I split it between the wheel, the road. I will draw the forces, the name OA. So this is the point O. This is O, A, and B. This is B on this element. This is A on this element, and C and C. Okay, so we have all our element and our pin connection. And what we know is that we know that the weight of the plane is 24. So if the weight of the plane is 24, and I assume it's on one, oh, that should be half. But anyway, I include that all the weight is on one of them. So this is the W, okay? So what do I draw this there? I draw this there because this W, if the W is there, if we look at the entire gear, it means that we also have the W there as a normal force. So we have a normal force there. Okay. So what does that mean? It means that this pin, that we have a force there, opposite of W. So we also have the W there. Okay. So here, the value of the force will be the weight of the plane. And again, it's because I assume that everything is on one landing gear. Let's say the weight of the plane is a double, and the W that we have left on one gear is 24 kilonewton. Okay, 24 kilonewton. Okay, so that's what we have. We need to analyze a bit all of that. What we see there, what is interesting is the two forces member, the road CD. So let me draw it in blue. CB, sorry. CB, it's a two forces member. This one has 3-pin connection. And we already know one value W. And let's draw this one in pink. And this one, we don't know what's happened on top there, so we cannot assume it's a two forces member at all. We don't know what's happened on top of this. So what we can look at is, what will be interesting is, if we do the moment about A, okay, we have the weights going clockwise, so the force at B should be counterclockwise. So we need to have a force going up like this. And why I draw it with the directions, we know that this force will be aligned with CB. So at CB, we'll go down, same value, same magnitude, opposite direction there. At B, we'll go up, but we know the direction, okay? We know the direction of this one. That will be that direction, this direction, okay? It's supposed to be a straight line, okay? Oops, this one. So when we will do the moment about A, we will have W time, we have this angle, 30, so we can find the value of W perpendicular to OA. But here B, and this looks perpendicular. Okay, B, this force B is not perpendicular to this one. Let me draw it a little bit more. You see, it's aligned with there, so it's a little bit more like this. Okay, it's not perpendicular, so we need to find the complement of this force at B perpendicular there. So we need to find this angle. Let's call that alpha. Okay, this is this angle on the drawing. This is this angle there in green, in pink. So how can we find this angle? We will go inside that triangle. Okay, that is not a right triangle, but we know 250 for AB, 700 for CB, and we have this angle. So this angle can help us finding this angle inside. Okay, so let me draw the triangle there. Oops. It looks a right triangle. Let me change that. Like this. Here we go. A, B, C. We have 700, 250. And we know that angle there is 30. So this angle inside, let me draw it purple. We know this angle will be 60 degrees. Okay. The angle that we want is this one, because if we have this one, we have this one on the side. Okay. That will be 90 plus this one. Okay, so how do we get this angle? Because we don't know this distance there. Let's do some, we have 700, let's do some sine law. So if we do the sine law, we can write that 700 divided by sine 60 equal 250 divided by this angle beta, sine beta. Okay, so we got sine beta that is equal to 250 divided by 700 times sine 60. And you do the inverse sine. So let's see how much do we get when we do this. Okay. So 18.1 degrees. And it makes sense that it's small, okay, that this angle on the top. So there we have 18.1 degrees. So if we want to find, let's call that gamma, we can use the fact that 180 is equal to 60 plus 18.1 plus gamma. So oops, we got gamma that is equal to 121 or 1.9 degrees. Okay. So that means that if we look at this yellow bar or A, so okay, let me clean that a little bit. Let me clean that. Remember what we are looking for? We are looking for this angle there between the perpendicular line. Zoop. Oh my God. Okay, you see what I mean? But the one going through B. Okay, let me do it through B. Oops. That keeps sliding on my screen. Oh, this one was good. Why did I lose it? This one was very good. Okay. Oh, this one. Can I just remember this one? Okay, here we go. That's perfect. So we have a total angle there of 101, 101.9. So this little angle there will be just minus 90. So this one will be 11.9 degrees. Okay, so let's use that to get the force at B. Okay, that's the only equation that we can solve for. If we do force on X, force on Y, we have too much unknowns because I didn't draw them, but if we draw them, we have AX and a y that will be down because everything else is up. Okay, so how do we find AX and AY? We cannot for now. We really need to do the moment. So AX, AY, we really need to do the moment about A first. So let's do that. Okay, sum of the moment about A equals 0. So I am in the yellow road. Yellow, oops. Okay, so we have W, this angle is 30 degrees. So W cosine 30 degrees time this distance, that is 250. So time 250. And this is in the negative direction. Plus this force that is at B. So let's call this force B. I will call this force, oops, this force FB. FB, FC, and what we are looking for is like the AX and AY. I could write FAX and FAY, doesn't matter. FAX, FAY, that makes more sense. Okay, so FB is there. So we have plus FB cosine 11.1 degrees, 11.9 degrees, time this distance, that is 250, equals 0. So we got FB equal W time cosine 30 divided by cosine 11.9 degrees. That's simple because it's the same distance. Let's check how much is that. So we got FB equal 21. 21 21.24. And that's also kilonewton. Okay, so we got the first step, FB. Now what we want is the force in A. Okay, so now we need to do some force on X and force on Y. So if we do sum of the forces on, doesn't matter, sum of the forces on X equals 0, we got W, that's 0 forces, so we just FAX, and my FB, so FB has an angle, oh, that's even another angle for FB. How much is that? At the angle that we found before, the 18.1. Oops, let me think. Okay, so let's look at this graph. I will look at this one on the right. So what we try to find, okay, I will just repeat. We try to find the complement on Bx, like FBx and FBy. We don't see anything with this green. Let's do this one. FBy and FBx. So we need an angle for that. Okay, we have the value of FB. FB is there. No, so that will be in that direction, okay? Sorry, that will be in that direction for FBx. So what we know, not that bad. We know this angle, 101.9 there, until this one. And we know that this distance, this angle there, is 30 degrees. So on X, we will have FB cosine 101.9 minus 30, because we want to have this one. This one 101.5 minus this one, the 30. Okay. And on Y, that will be FB sine the 101.9 minus 30. Okay. So that the two complements on. I will draw them again just for you so we can see again, and let's try something that we can see. So this is FB. Okay, and we try to find FBx and FBy. Okay, so what we know is this 101.9, that is this angle. Okay, in orange. And let's try to call this in blue, we know also this angle is 30 degrees. So that's why I have 101.9 minus 30, because I just want that angle inside. Okay? So let's come back to our equation, sum of the forces on X equals 0. Sum of the forces on X equals 0, so we don't have W, we just have, I am on that free body diagram, so we just have FAX, and the Bx will be minus FB, and we see on X it's cosine 101.9 minus 30 degrees equals 0. So we got FAX equal, let me check, equals 6.60 kilonewton. And now if we do the sum of the forces on Y equals 0, we have this one, we have W going up, W, minus FAY, and plus the FB sine 101.9 minus 30 degrees equals 0. So we have FAY equal W plus FB, that's my 21.24, and sine 71.9 degrees equals 0. Oops. So we got FAY, so this one will be larger. Okay, how much is that? It's equal to 44.2 kilonewton. And to find A, we need to take the square root. So A equals the square root of FAX square plus FAY square. So this is the square root of 6.6 square plus 44.2 square, how much it is, and this is 44.7 kilonewton. Here we go. That's what you should get for this example with those data. Let me know if you have questions for this problem. And I know machines are tricky because they're all a little bit different, but again, the key is watch for two forces member. So this one is a two forces member. And after that, watch for equation of moment first. Okay. Geometry could be tricky, so look for cosine law, sine law, right angles, opposite angles, and things like that. Let me know if you have any questions. Bye-bye. Have a great day.